Okie dokie, are we ready? All planned out? Come on back. Let's take a look at you. Okie dokie. So let's just do a quick summary of topic 3, which is basically this right here. Okay. So topic 3, key points. Sample comes from a population. Population is the entire collection of observational units that we want to know something about. A sample is the piece that we pull out of that in order to make the analysis. Most times we will not be able to make an analysis of a whole population. The sample gives us a statistic, and if we've done everything right, no bias, and done it properly, we can take that statistic and say that is a parameter. So the statistic is describing the sample, and the parameter is describing the population. But getting parameters is really hard to do because populations are generally too large. So we did take samples, we get statistics, and then we can infer a parameter. We're not dealing with sampling frame, not that important right now. Again, this is going to get me thrown out of the American Statistical Society, which isn't a problem because I'm not really a member. But if I was, they would throw me out. An explanatory variable causes the response variable. We're looking, and it doesn't really cause it, but we're looking for that kind of a relationship where if one variable could cause another variable, the first one is the explanatory, and the second one is the response. The explanatory kind of explains the response that we're getting. Sampling bias is where we overrepresent some parts of the population and underrepresent other parts of the population. And if we have sampling bias, we cannot generalize to the population. We have bias. And observational study is one where we all just go out and look at the real world and gather a bunch of data, and then try to analyze it, see if we can find correlations, see if we can find associations, analyze the populations with samples and statistics. But observational study cannot give us a cause and effect conclusion. We can only get cause and effect conclusions from experiments. experiments. Right? We cannot get them from observational studies. We can get some pretty good ideas from observational studies. We can get enough information to develop a policy, but we cannot prove cause and effect. And part of the reason for that is that there might be, when you do an observational study, there's a lot of variables that are kind of hidden variables, HIDDEN, that may not be accounted for. So, I'm not worried about confounding or lurking. I just need you to know that you need to look to see if there's other variables that might be hidden when you do an observational study, that would then make it invalidate your conclusions. All right, we're relatively clear. We're okay with this. Yes, I'm seeing nods. Okay, good. All right, then we're done with topic 3. And we are boogieing over to topic 4. I sent out a copy of the Gettysburg Address. Did everybody get it? Okay, now I'm not talking about the chart that I handed out. I don't want you to look at the chart, but I do want you to open up the Gettysburg Address. I want you to have the Gettysburg Address in front of you in a little bit. Okay, so we're going to talk a lot more about sampling bias. We're going to talk about a simple random sample, which is like the gold standard for all kind of statistical analysis, and how come it eliminates sampling bias, which is an amazing thing. we're going to actually implement random sampling to select a sample from a population. And we're going to talk about the irrelevance of population size on precision. That'll be eye-opening for everybody. And then these are the practice problems and activities that you should definitely be able to do. So there's the self-check activity, and there's 1, 2, 3, 4, 5, 6 exercises that you should do. So we're not putting an undue burden on you to do a lot of extra work. So let's get started here. No. Okay. We know that. We know that. Go. Okay. So, looking at the Gettysburg Address, I want you each to guess how many words are in the Gettysburg Address. Okay. So, Alexi, how many words do you think are in the Gettysburg Address? I'm just going along my line here.
410.
410. Okay. Karina, how many words?
350.
350. Okay. Imani, how many words?
450.
450. Emma?
500.
500. Okay, Megan?
I think it's only like 250.
You think it's like 250? Okay. Isa, how many words in the Gettysburg Address?
600.
600. Brooklyn?
About 300.
About 300 words in the Gettysburg Address. Juliana?
Like 270.
270. Isabella?
I also think 250.
250. Alexis?
275.
275. Sylvia?
310.
310. Alondra?
450.
450?
Yes.
450. Okay. We'll leave it right there. Okay, that's interesting. All right, so the Gettysburg Address has 268 words. So actually, this is pretty good. These are some pretty good guesses. The biggest one was 600. The other class, somebody guessed 1,000. But I'm guessing that they didn't take a good look at this. You know, there's not 1,000 words there. I don't know. I guess if you aren't used to counting words. So the Gettysburg Address has 268 words. Does anybody know how much a score is? 407 years ago. What's a score? How much is a score? Nobody knows how much a score is. A score is 20 years. So now you know. Pretty soon, you guys will be a score years old. Score, goal. That's right. All right. So, so we're going to look at what sampling bias is, and we're going to anticipate the direction of sampling bias based on a particular sampling method. So, what I want you to do is everybody look at the Gettysburg Address, and I want you to pick 10 words out of the Gettysburg Address. Just look at the Gettysburg Address and pick out 10 words. Write the 10 words down. And then count how many letters you have in each word. Okay, so just write the 10 words down and then count the number of letters in the words that you picked out. Does everybody have, hey guys, put on your cameras, okay? I can't, it's hard to teach a class without any visuals here. Good. I was gonna ask a question. And now I forgot. What was the question? Everybody has a Gettysburg Address, right? Okay, nobody needs a copy. All right, good. All right. 10 words, count the number of letters. Anybody done? Done? Okay, give me another minute. And then we're gonna go to the magic bowl and somebody's gonna help us make a dot plot. Ooh, how exciting is that? That's like super exciting. All righty. So, yeah, the one person who's not here, Raina. Wait, is that the only person? So I got what, 15? No, I got 12, 13. How many? I better take roll here. Hang on a second. 13. Oh no, I'm missing like 3 people. I'm missing, I know I'm missing Raina. Oh, I'm missing Caitlin. I think she was at a college thing. And no, oh, Abby. Abby's also at a college thing. All right, so they're all at college things, so that's fine. Oh, Abby is at a dentist or something like that. So I'll put her absent. Okay, fine. Okay, sorry, I don't like to do that during class, but that's the way it is. Okay, so Raina is not here. We're gonna ask Sylvia. Sylvia, so you're 10 words, okay? How many letters in the first word?
4.
So 4 letters in the first word. And how about the second word?
5.
And then the next one?
3.
Next one?
1, 2, 3, 4. 5.
5 again, so that dot goes on top of it, yeah.
And then
Next.
5.
Another 5?
Yes.
Okay, keep going.
3.
3,
3.
3,
6.
6,
7.
7,
And 5.
and 5 again. Okay, good. Good, very good. All right, Sylvia, what are the observational units in your dot plot here?
The observational units would be the words.
Very good, they would be the words. And what is the variable?
The number of letters in each word.
You're right on target. Number of letters. And is that a quantitative or a categorical variable?
Quantitative.
That is a quantitative variable. Very good, very good. Okay, good. So what I want all of you to do is calculate the average, the mean number of letters per word in your sample. Okay, so add up all the letters that you had, and if you had 10 words, you divide by 10. That'll give us the average number of letters per word in your sample. Hi, Caitlin. How are you?
Sorry, Mike. Sorry, I just joined. My connection's really bad. Did you say something?
Yes, I said, how are you?
Oh, I'm good. How are you?
So what I want you to do is, you got the Gettysburg Address that I sent out?
Yes.
Okay, I want you to pick 10 words, any 10 words that you want, and I want you to count the number of letters in each word, and then figure out the average number of letters in each word.
Okay.
Got it?
Yes.
Good, then you're gonna be right with us, okay? So, okay, so finished? Everybody done? Yes. Okay. So Alexi, what average number of? Wait, hang on a second here. Somebody's chatting here. Okay, that's fine. All right. So Alexi, what would the average number of letters in your words?
The average was about. Shoot, wait. I thought someone was coming up. I mean, I added them all together and I got 69.5.
So you divide by 10, that would be 6.95, right?
Yes.
Great. So you'll put your dot right here. So your average number of letters was 6.95. Okay,
Yes.
Karina, how about you?
Mine was 4.9.
4.9. So all right about there. Okay, Imani, what about you?
Mine was 4.5.
4.5. So you're right there. Okay, Megan.
5.6.
5.6. Sylvia.
5.3.
5.3. Juliana.
3.5.
3.5. Okay, Alondra.
5.6.
5.6. So I think we have one 5.6. So we'll put it right on top of it right there. That's good. Okay, Isabella.
I have 6.2. Oh, sorry, there's two Isabellas.
Oh, the Isabella Japounda. That's right. You.
Oh, 6.2.
6.2. Wait. No, we only have one Isabella in this class.
I thought we had Isa
What?
Ramirez.
Oh, okay.
Was she-
I call her Isa. Okay, that's fine. Okay, I gotcha. Okay, fine. Okay, fine. All right. So now everybody moved around there. I got Juliana. Alexis, what do you have?
7.
7. Ooh, right on the nose there, huh? 7. Isa.
5.5.
5.5. So right next to it over here. Oh, this is so interesting. Caitlin, what'd you get?
4.1.
4.1. Good. So Abby, Brooklyn, what did you get?
5.
5. Okay. So Abby, what we have done right now is everybody pick 10 words out of the Gettysburg Address. Okay. You don't need to do it. You'll catch on. And then they gave me the average number of letters in their sample of 10. You got it? You follow what I'm saying?
I'm a little confused.
Okay. So I sent out a copy of the Gettysburg Address, which looked like this. And everybody picked 10 words. They just picked 10 words and they counted the number of letters. And then they gave me the average number of letters per word. Are you okay with that? Good?
Yeah.
Okay, good. All right. So what this represents right here is a dot plot of the average number of letters per word for everybody's sample. We good? Okay. So I'm going to repeat that one more time because Raina just popped in. Hello, Raina. We all just went through the Gettysburg Address, and everybody picked out 10 words. You don't need to do this. You'll be able to follow along without it. Everybody picked out 10 words, and they counted the number of letters in each word, and then they calculated the average number of letters in the words that they picked out. Are you with me? Okay, great. And so we just made a dot plot of that. So for example, wrong one here. Here's a dot plot. So Juliana, I think it was, her average number of letters was 3.5, right? And then somebody else's average number of letters was 7. Okay, so what I want to know is well, let me say this first. The y-axis here, if we put a y-axis in here, is simply the count. The number of dots for each particular value here. So like, this 5.6 had 2 and everybody else had 1. Right? But what will we label the x-axis here? How will we label the x-axis, Alondra? Not the easiest question.
Could we say number of letters per word or average of letters per word?
Yes. So average number letters per word of what? From what?
The Declaration of Independence. Wait.
Close.
Gettysburg
Actually, the first was the Gettysburg Address, so that was way far away. But that was 77 years later, actually. But just so you know where that comes from. But no, what do each of these dots represent? What does your dot represent, Alondra? What did your dot represent?
Mine was 5.6, which was the average number of letters in the words I chose.
And the words that you chose are called a what? From the population of all the words in the Gettysburg Address, you pulled out a what?
Random sample.
You pulled out, well, random is issuable, is questionable, but you pulled out a sample, right? Average number of letters per word, we'll say 4 10-word sample. Okay, so I'm going to take a little snip of this and I'm going to move it over here to the next page. Oh, well, we just did observational units and the variable, so that's okay. Everybody okay? Observational units are, well, no, let's ask that question. What are the observational units here? What are the observational units? Alondra again.
Would it be no. I'm not sure.
Well, so each dot represents an observational unit.
So the words.
Yes, you're close. Close enough for government work, but let's use the proper terminology, which we just did a minute ago.
Samples.
Yeah, the observational units are the 10-word samples. 10-word samples. Each dot represents a 10-word sample. And the variable is Emma, what's the variable?
The letters?
You're close. Something about the letters.
The number of letters?
Yes. We'll call the average number of letters. Right, that's what was varying between each word sample. This one had 3.5, 4.1, 4.5. Everybody with me here? This is like a slightly higher level of abstraction from what we were doing before, because we're not just analyzing like what are the observational units, we're analyzing each observational unit is a particular sample. All right, so the actual average number of letters per word in all 268 words is 4.29. Now, isn't that interesting? Because our dot plot, whoops, where did that go? How did that happen? Let's get rid of that. Let's go back to our dot plot here. Copy, paste. There we go. Here's our dot plot. So the actual average number of letters is 4.29. It's looking like to me that almost every single person got an average that was higher than the actual average. Only 2 people produced a sample lower. So why? Why do you think that would happen? Is there some kind of bias going on here? Are the smaller words underrepresented? Are the larger words overrepresented? Why? I'll take a volunteer. Well, then we'll have to go to the magic ball. The magic ball. You're gonna say something? Go ahead. Raina, were you gonna say something? You've now frozen. Megan, were you gonna say something?
Yeah, well, I just think that maybe people avoided smaller words like and or a, so they went for longer words.
I think that's probably true. I mean, you're reading the Gettysburg Address. I mean, honestly, if I'm picking out 10 words, I'm really not looking at or so, you know, or to, you know, I'm looking at like hallow and unfinished and devotion. I'm looking at like the chunky words that mean something, right? So the sampling method that we just employed here, where I just said, hey, pick out 10 words, that was a biased sampling method. I think everybody would certainly in my experience doing this particular experiment, everybody always gravitates towards longer words, except for Juliana. So you're the what words did you pick, Juliana? Let me hear your words.
I picked the and and the ors and like the those, but I just did that because I wanted to like be able, if you were to call on me, like give you the numbers quickly. But
oh, so you were consciously biased towards the small letters because you wanted to be able to add them up quick. All right. Well, that's interesting. I never would have thought about that particular bias, right? But okay, that's legit. It's biased anyways, you know, but that's okay. I'm all for that. All right, that's good. That's good. All right, so so it's biased. Now, what if I said, put the Gettysburg Address in front of you and take your pen, close your eyes, and just touch 10 words, right? So you're closing your eyes and you're just touching 10 words, and then you do it that way. Do you think that would be unbiased, or would it be biased?
Unbiased.
You think unbiased? Why? Because your eyes are closed?
Well, yeah, because it's random, because you're not, unless like memorize it and you've printed it out and you've read it a million times, each and every word is going to be like, you're not going to get the same words that you chose unless it's like an and or like a the.
Okay. All right, does anybody have a different opinion? Caitlin, you have a different opinion. What's your opinion?
I think it would be biased because the longer words, like, they take up more space. So I feel like you have more of a chance of selecting them on the page.
So what do you think about that, Alexis?
It's definitely a factor. I think that's definitely, it's true. No, that's wrong.
Yeah, I think that's an important factor. Did I interrupt you, Caitlin? What were you going to say? Something else?
Oh no, that's it.
Okay, yeah, I think because the longer words, they're longer words. They're bigger. They take up more space, so you're more likely to hit it. So so what we're going to do is we're going to do something completely different here. So if we want to avoid bias, this is like, I'm highlighting this here. So this is important. If you want to avoid bias, you have to give every single member of the population the exact same chance of being selected for the sample. That's kind of like the key to avoiding bias is everybody in the population has to be able to has to have an equal chance of being selected. And that is called a simple random sample. And that is like the best kind of sample you can have. everybody has the same chance of getting picked. So what we're going to do is we're going to give every single observational unit in our population of the Gettysburg Address, that is every single word in the Gettysburg Address, we are going to give it a unique number. That was the second thing I sent out to you guys, right? Yesterday. Let me, that is this right here. Hang on a second. Gettysburg Address word chart. Let's look at it like that. Everybody, did you all get that? Everybody got that? Yes? Yes. So 268 words, and every single one of them has its own number. So number 40 is the word testing, and number 125 is the word who, and number 218 is the word gave. And so everyone has their own unique number. And what we're going to do is we're going to have a method by which we can select 10 numbers at random. So everybody go get your calculator. Here we get to use the calculator. Your good friend. Everybody have a calculator. Anybody does not have a calculator? No. Caitlin, you don't have a calculator.
I normally have it, but I don't have it with me.
Okay. Well, hey, watch along. Okay.
Okay.
Mr. Jenkins.
Yes.
I also don't have mine. It's somewhere in my room, but I don't know where it is.
So I'm astounded. Okay, really? All right. So I'm going to tell you something, everybody. If you, and I've said this before, but well, two things. One, if you lose your calculator and you need a calculator, let me know. And if you go into school, I still have a bunch, and I will loan you one for the semester. All right. So I have calculators that you can borrow. But the other thing that you can do is there is an app you can download for free. So if you look at my apps right here, let's see here. Can you see it? It is the third column up. So the bottom column only has Zoom, and the third column up has an app. You can't really read it that well, but it's called WabbitEmu, WabbitEmu. I have no idea where that comes from, but if you download that WabbitEmu, what you get is a fully functional TI-84 calculator on your cell phone. Not as good as Desmos on your cell phone. Not as important when you're going out on a date. I have something else that you need when you go out on a date. But yeah, so it's really great. Oh wait, my mom is calling. Too bad, I declined it. All right. All right, so fully functional TI-84 calculator right on your cell phone. You know, I'm just going to check this for a second. I'm sorry. Mom, I'm teaching a class. You okay? Okay. All right. So my mom fell last night, and she tore up her knee, and she spent the night in the emergency room. And so, but she's okay. That's how come I got up so quick, because I know that she's okay. I already talked to her a couple times. But, you know, when you get to be 92 years old, did you know, I didn't know this, but that your skin gets really thin. Did you know that? Old people's skin is really thin. So it's like a piece of parchment paper. So when she falls, I mean, and she cuts herself, I mean, you know, plus she has blood thinners, you know, she's like bleeding like a fish, you know, I mean, it's just all over the place. So it's kind of a drag. And it's hard to stitch up because your skin's so thin, you know. What can I say? All right. You can say, Mom, don't fall. Use your walker, Mom, don't fall. Okay. All right, so those of you who have a TI calculator, here's what we're going to do. I'm going to call my TI calculator up. There you go. TI calculator right next to my Spotify. And let's clear that. And we're going to do, this is actually really very fun, okay? So what I want you to do is I want you to push the button that says math. And, you know, Imani and Caitlin, if you want to try and download that program right now, you can do it with us, but it's up to you. Wabbitemu, W-A-B-B-I-T-E-M-U. Okay, I want you to go math, and you see along the top, it says there's a menu, and the far one on the far right is PRB. So I want you to scroll over to PRB. That stands for probability. And the fifth one down says randint. That is a function that generates a random integer. So I want you to go down to 5, and I want you to hit enter. Now, does your screen look like that? Does anybody's screen not look like that? Somebody's probably doesn't. It doesn't. Okay, okay. So your screen, what I want you to do is this. To make it look like that, I'm going to go backwards. I want you to press the mode button. And I want you to scroll all the way down to the bottom. Mine is in 2 screens. Your might only be 1. And there's a function down here that says Stat Wizards. You see it? Stat Wizards. And I want you to turn it off. I want Stat Wizards off. So if you do that, and then you go back to the main screen, and you go math, probability 5, it's going to say random integer, and we want a random integer between 1, comma is above the 7, and 268. Close parentheses. Everybody there? Yes? Now hit enter.
Where's the comma again?
The comma is right above the 7. Raina, you're looking like, what? There's no comma there. There is a comma there, right above the 7. Maybe it's a blank, maybe it got rubbed off. Do you see it? Okay, now, I'm gonna show you guys how, do you know what the word clairvoyant means? Clairvoyant means I can tell the future. So I am clairvoyant, right? And I'm closing my eyes. And I'm guessing that there are at least several of you that have the number 253. Anybody have the number 253? How about that? How did I know? It's a random number generator. Yet I knew that you had the number 253 because I could see through the screen. Individual. Okay, so here's the deal. This is what is called a pseudo random number generator. It has an algorithm, and for most of our purposes, it generates a random number. But the fact is that all you people with 253, you have never used it before. So you come with the factory setting, which is what generated 253. So what we're going to do is we are going to seed your calculators so they will be different. Right? So what I want you to do now is I want you to enter in the last 4 digits of your cell phone number. So my last 4 digits are 3375. Okay, so put those into your calculator. And then I want you to push the math button. No. Go back. Second, quit. You're back to the main screen, 3375. Everybody there? Yes? Okay. I want you to push the button down here, way on the left-hand side, just above the on button that says STO. That's store. So now you should have a little arrow. It should say the last 4 digits of your cell phone number and a little arrow. And then I want you to go to math and back over to probability. And the very first one says RAND. I want you to enter that one there. So now it should look like this. Last 4 digits, arrow into RAND. Everybody there? Now press enter, and you have just seeded your random number generator. So unless 2 of you have the exact same cell phone number, the last 4 digits, which I think is highly unlikely, Then now if we go math, probability, 5, 1, comma, 2, 6, 8, end parentheses, and we press enter, everybody should have a different number. Very unlikely that we would get 2 of the same. I guess it's possible we could get 2 of the same, but I really doubt that we would get 3 of the same. So, so Amani, what's your number?
The last 4 digits of it.
No, the one that after you did rand int, comma 1, comma 268, or did you
Oh,
not do that yet?
I haven't gotten there.
Okay, go ahead, get there.
Um,
Or did you get the last 4 digits? Do you want me to walk you through that again?
I think, okay, I got 18.
18.
Yeah.
Okay, Emma,
I got 124.
Megan,
156.
Brooklyn.
I didn't, after you did the random generator,
Yeah.
I like got lost. So I
Okay.
don't know.
Okay. What number did you come up with in your first time? Do you remember?
Well, that's what I got like lost on. Like
Oh, okay. All right. So here, let's get you unlost. Press the math button. Then scroll over to probability, PRB. And you have this menu that looks like this right here. Number 5, so press 5. And it should say rand int with a parentheses. Now go 1. Then the comma, which is above the 7. And then 268. So you're asking your calculator for a random number between 1 and 268. Now press enter. What'd you get?
I got 72.
Great. Okay, so you got the same number as me. That's interesting. That's coincidental. Alexi, what'd you get?
Oh my god, wait. I never thought I could do this. I just found out something on my calculator, but like it's random number, right?
Yes.
Random
No, random integer.
integer. I got an error. What the?
I'll come back and help you in just a second. Caitlin.
Okay.
I tried getting the app, but then it said that I needed like pro, like I needed to pay to do that. So
No pay. No pay.
Oh, wait. I know what I'm doing.
Okay. Alexis, what'd you get?
5.
But I thought the one we had originally received.
255.
Okay. So Isabella, what'd you get?
Oh, okay.
I got 40.
Oh, good. Reina.
I got 198.
Great. Alondra.
173.
Karina.
248.
Abby.
Next week.
132.
Isa. Another 72. That's interesting. Okay, Juliana.
31.
And Sylvia.
53.
Okay, so we got a wide variety here. I want to ask, so Isa, do me a favor, okay? Do it again like I did it. Rand in 1, comma 268. What do you get?
Do I keep running the one I've been running for this week, or swap over to the one that's in?
Isa. Isa, are you there? I see you. You can't hear me? Okay. That's not good. You should be able to hear me. Leave and come back. Okay. Who else got 72? Somebody else got 72. Come on, who else got 72? Somebody else got 72. No? I made that up?
Oh, I had 72.
Okay, Brooklyn, then do this. Do it again. Do rand in 1, comma 268. Tell me what you get.
I got 179.
So you and I are kind of like in sync here. See, this is what a pseudo random number generator does. It kind of is it's pretty good, but it's not the best. So I'm just going to do this. I'm going to go 5, 4, 8, and I'm going to store that into my round. Oops. Okay, now we'll have different ones. All right. So, all right. So I want to show you something that again about random number generating here. So this is pretty good. Actually, I'm going to tell you what we're going to do, and then I'm going to show you something about random number generating. I'm giving you a homework assignment, believe it or not. I'm giving you an assignment. And what your job is to take this sheet right here. And so I came up with a random integer of 179. So that means my first word was fought, F-O-U-G-H-T, 6 letters. You follow me there? Right. And if you had the number 72, which I did, then that word was of, O-F. So every one of these letters, every one of these words has an equal chance of being selected. So your homework assignment is to do this rand int 1 to 68 10 times and get the average number of letters. You with me here? This is not a long homework assignment. Is everybody clear on what I'm asking you to do? Everybody's okay with that? Okay, so now for Caitlin and Imani who don't have their calculators, here's what, you listen carefully because I'm going to tell everybody something really cool here. So something really awesome is a website. And the website is random.org. So this is the actual, as far as I know, the only true random number generator on the internet. And you can generate all sorts of numbers here. So, but we're going to look over here at the top. See, look, we got games and we got drawings and web tools and stats and all this stuff, right? But we're going to go to numbers and we're going to look for integers. So it says, okay, I want to generate, I'm going to be really generous here. I'm going to generate 10,000, wow, 10,000 random integers. And each integer should have a value between 1 and 268. So I can define that. And I want it formatted in, I don't know, let's say 10 columns. And I go get numbers. And there we have 10,000 random integers formatted in 10 columns, all of them between 1 and 268. Now, how this works, does anybody ever watch, like the TV, and there's nothing on, and it's like the gray screen, and there's all these black and white dots that are flashing on it. You know what I'm talking about? Just like the static. You know what I'm talking about? Yes? Yeah. Do you know what those little black dots are? Anybody know what they are? This is going to blow your mind. I'm just telling you. Nobody knows what they are.
Aren't they just random numbers and colors in like small like pictures?
No. What they are gamma rays from the Big Bang. So the Big Bang, I don't know, was it 13 billion years ago, something like that, right? The Big Bang sent out all these gamma rays and they're flying around the universe and they are hitting your television screen and making a little black dot. And somehow random.org has managed to capture that randomness, and those are true random numbers. Now, the important thing though is that, come on, go away. Uh-oh. Come on, go away. Try again. There we go, got rid of it, okay. Look on your cell phone. You can download random.org onto your cell phone and generate random numbers. This is important when you're on a date. You never know when you need a random number generator, right? So look, I'm going to randomize between 1 and 100. Look, 37 or 60. I'm sorry, I'm not seeing enough excitement here. I mean, you can have your very own free random number generator on your cell phone. Not only that, you can do integers, you can do, oh, look, you can do lottery numbers. You can do cards from a deck. Look, Jack of Diamonds, random. Next card, King of Spades, random. I mean, come on. Dice. Look, I can do dice. Wait, randomize. I got a 1. See, this is like totally cool. Because hours and hours of enjoyment on your random, they're free. This one is free. I'll have an email. I don't know why they told you had to pay for it. How much were they asking you for? Are you looking? No? Okay. Well, maybe I spent $2.99. It's of course a lot cheaper than the actual calculator if you go think about it. But okay. So you know how to do random numbers. You know your assignment for next lesson. Yeah, and we're going to do it that way. Okay, so 10 minutes early, go have fun. All right, do your homework. We'll see you later.
Thank you, Mr. Jenkins.
Thank you.
Bye.
Bye.
Wait, I have a quick question.
Yes, I'm right here. I'm not going anywhere.
Can you just like say again what the assignment is? Like, how did we do it?
Yeah. So you know how to get the random numbers on your calculator, right?
Yeah.
So I want you to do that 10 times. So you'll have 10 random numbers.
Okay.
And then I want you to go to I'll just share it again. I want you to go to this chart that I sent out.
Mm-hmm.
And so let's say your first one was 64, right?
Yeah.
Then your word is war, 3 letters. Do that 10 times and then find the average number of letters.
Oh, okay.
You got it?
Yeah.
Yeah.
Sounds good.
All
Okay,
right, good.
thank you.
All right, Karina, see you later.
Bye.